10 minutes of the recording. So thank you all for joining in for this last session of day 2 of our workshop. This last tutorial is about visualization of the data that comes out of VCPL, that comes out of SimVascular, and that comes out of Chased. Most of these, all of these platforms provide output in 2 manners. Firstly, they will provide outputs at desired locations in text format. And so ASCII output is an option. A strong suggestion is that you do not pursue that option because that slows down your simulation considerably. And the second option that you have is of ParaView Vtk outputs. Now, Vtk outputs can be organized in several different manners. Many years ago, I used to work with legacy Vtk files. Legacy Vtk files come with a simple ASCII header, and you can either write in ASCII or as a binary dump all of your structured lattice data. This can be a scalar field or this can be a vector field. So legacy Vtk has a header followed by either a binary dump or ASCII write-up of a structured data, either of a scalar field or of a vector field. Now, scalar fields and vector fields can also be handled by a form of writing data called visualization toolkit in points. And so the files will have extension of VTP. And this is, in these VTP files, is a point cloud describing whatever data it is that you put in there. Furthermore, there are 2 file formats provided by the Vtk library that write mesh data in addition to the points data. The first is the VTS file, which stands for structured mesh data. So the S in the VTS stands for structured mesh. As well as there is a final file format called VTU. And the U in the VTU stands for unstructured mesh. Now, what Jeremiah's pre-recorded presentation is about to show you is how to speed up your visualization process. And just to have a picture in our minds on how the visualization process works, I'm about to show you how to do it interactively. So here's me sharing my screen over here. Now, I have already downloaded several files from the list of files that Tim has shared with us. It has 2 classes of files. One is the VTP. So point clouds have been written to these files called all results something.vtp. And then there is another class of file that has data written in mesh form, and that has an extension of visualization toolkit unstructured mesh. Okay, so feel free to take any one kind of file, and I've taken the first 5 or 6, half a dozen or so files, which I'm about to demonstrate to you with. And so the first step here is that you are looking for a software called ParaView. In as much as SimVascular has a graphical user interface, ParaView is a graphical user interface of an exceedingly powerful kitware library called VTK. VTK, all written in caps, stands for Visualization Toolkit. This library is programmed in all our platforms, Chased, SimVascular, as well as the platform I developed, VCPL. And so you either use ParaView or you can hard code the visualization into your platform such that the outputs are already somewhat processed to your liking. However, let's start with the VTK files that Tim has provided us. and see how we can manage to visualize them with VTK's graphical user interface called ParaView. I've written ParaView, the word here, on my terminal, and I'm about to start this program. And so tell me if you do not see a sort of massive screen come up with a white sort of squarish rectangle in the middle with lots of ribbons, option ribbons at the top, and a pull down menu right at the top. I'm using a Macintosh computer right now. And so this is what your visualization ParaView GUI looks like. The VTK GUI called ParaView looks like when you start the thing. Your visualization window, your render view, may have a gray background. I strongly suggest that you use a clear white background, because often when you're happy with your visualizations, you may wish to print your diagrams to see that they actually print at an acceptable quality. So I always have a white background. Before we proceed, a very strong suggestion, in fact, that is a policy that I have, is that the version of ParaView that PM3 likes is ParaView 5.8.1. So I like the version 5.8.1. What I mean by I like it is that if you use ParaView 5.8.1, I can support you for everything that Jermiah is about to tell you in his video. Okay? Regardless of that, the first step in visualizing your simulation output of the VTK kind is to load the data into this GUI, done by the pull-down menu at the top somewhere to the left-hand corner called File. So you go File, and there is an option in File called Open. There's also a shortcut here. It goes Apple O. So let's try Apple O. I've never tried Apple O. So perhaps Apple O will bring me to a place where I can upload or import the VTK data into ParaView. So here's me pressing Apple O, Command O. And something did come up. This option here asks me which file should I open. It goes File Open, open multiple files using your Control key. Now in the options over here, because I have a string of files with similar prefixes, only difference being the sequential numbering of them, ParaView double guesses you and assumes that these files here belong to the same class of file, belong to the same simulation output. And therefore, ParaView sort of thinks that I want to import them all at once as part of the same simulation, which in this case is true. And so you highlight the thing and you import the thing by pressing OK. And as soon as you've pressed OK, especially in case of SimVascular outputs, not in case of chaste, not in case of VCPL, but in case of SimVascular, SimVascular is organized in such a way that as soon as it writes some output, it chooses to write everything it knows unless you tell it not to write specific things, okay? And so in this case, it looks like the simulation chose that everything should be written. So what is accessible to SimVascular? Let's take stock of what is accessible to SimVascular when it chooses to write VTK files, okay? It has the finite element ID available. It has the individual finite element node ID available. Furthermore, average pressure, average speed are available to SimVascular, and that it has written to these VTP files. There's also time derivative of something available. There's a VWSS that is available. I'm guessing it is wall shear stress of some description. There's a velocity available. Now, as soon as the word velocity comes up, people like me think that this is more a vector field rather than a scalar field. And therefore, you may be able to draw you may be able to draw streamlines using this data rather than just visualize a point cloud. Okay. We can try that in a minute. We can try that, but I do not expect success because I haven't seen this data before. Okay, and so all of this lot of information is available to you. The importing of the data is not finished unless you categorically confirm by pressing on this blue button over here. This blue button for you might live elsewhere in some other place on your screen. Okay, and so you have to go and promptly press on that blue button. It has a think, and because Tim is really clever, and because I'm not so clever, up comes a really good-looking picture here. And because of how I have set up my local peer review, I always get a color bar to the side. I always get a right-handed axis. So if this is X and that is Y, so if my curling hand is going from X to Y, then that is the direction of my Z. Okay, right-handed thumb rule. And I like to have my axis there. You might appreciate, again, the reason for why I have a white background here, because I like everything written in black, and I have lots of colorful pictures all the time. One of the sort of playful things that you can do is you can pick and choose a whole bunch of color schemes. Now, as a digression, these color schemes are available to everything that is visual. Specifically, in our case, these things are available to Fiji. These lookup tables are available to 3D Slicer, and in this case, this is available to Caraview. And you can pick a whole bunch of color schemes. Quite often, I like to choose only a finite number of colors, so that I can roughly interpret how things are going. Okay, so today I might pick a finite number of colors. As I said, the color scheme is as much aesthetic as the scientific requirement. So you can pick any. Quite often, a lot of scientific visualizations rely on the HSV lookup table. But today, just for the sake of amusement, we might choose blot. And if I apply that lookup table, and then I close this preset, you can see that the colors are now clumped. So the colors are assigned such that if the value of pressure is in between certain ranges, it's clumped over there. Now, what happens quite often, especially in case of vasculature people, is that we have really large vessels, and off of them are hanging really small vessels, you know, like the images we saw yesterday, both in livers and brains and whatnots, hearts, whatever. Yeah. And if you have got such nonlinear change of diameter and lengths, it is often useful to use a log scale for your visualization rather than a linear scale, for which there is an option here. Today, we may not need a log scale, but you can see that the minimum value I have here in terms of pressure is already 10 to the 5, 13, 10 to 1.3, 10 to 5, and the max is also roughly about 10 to the 5. So there's not much of a range over here. So I might wish to sort of make my minimum and maximum a bit divergent by using a log scale. And so if I use a log scale, it becomes that much clearer. Several options. You must pay attention to the top strips over here. And the top strips, options in the top strips that I'm really interested in now is adjust your color bar range to what your data says. And that is shown by this two-sided arrow over here. Okay. And so it adjusts somewhat unless it hasn't adjusted. That's fine with me. That's fine. Now, unlike YouTube, the purpose of scientific visualization is firstly, do your simulation, and then late at night when no one is looking, take your data and make pictures of your data and convince yourself that the whole thing is working. First purpose. Okay, that's the first purpose. But fine. For that purpose, getting so far is fine. So you've put your data in here. You've seen a picture. There's lots of colorful pictures over here. You can also press on this play button if you've uploaded a sort of dynamic change of variable here. And you can see that something did happen. So I'll run this visualization again. And this is going to run over 7 frames. And so for the first 4 or 5 frames, nothing happens. And then a little bit of a distribution of pressure comes up. So you can do this all night long, all day long, just to convince yourself that your simulation is working. However, we are all of us attached to one institution, 2 institutions, or many institutions for the sake of learning, for the sake of getting theses done, showing, disseminating your research. And for that purpose, you want to somehow record your visualizations, okay? And so with prudent use of mouse and with prudent use of this large range of filters that you have, these are various functions that you can do to your visualization. You can also sort of go to your properties, and you can annotate your visualization by writing text there. And you can say, give it a sensible name, you know, give your visualization a sensible name, okay? Yeah. And the purpose of this is that after you're happy with your visualization, and supposing by some slim chance you are now convinced that your results are proper, you have now shown something new in this said aneurysm, this said cerebral aneurysm. You now need to record this. And to record this, you do the following, is that from the file menu, okay, you pick the save animation option, okay? And with the save animation option, there are some of us who like to save a video directly from Png, something that I choose not to do for various reasons. I choose to output individual images of high quality, okay? And you have the choice of writing a prefix there. So my fav prefix. And as soon as you've written a prefix over there, Png may at some point go and write files my favorite prefix 1, my favorite prefix 2, so until 6, or however many files you have there, okay? And that process starts when I press on this OK button over here, okay? And so all being well, let's open a file browser. You can see that all I have is VTP here. I'm not lying, there are no PNG files here. We are about to create the PNG files by pressing on this magical button, OK. Let me cross my fingers and press on OK. But fine, it hasn't started because it thinks I need something more. And my general choice is not to have any compression at all. However, for today's purpose, let's have a OK compression and leave it at that. Make your image pixel size as big as you can help it. Reducing the size of your images by dragging and dropping is okay. Having a small picture to start with and then stretching it out is not okay. All right. And so again, let's try pressing OK and see what happens. It goes and has a think and is gone and saved an animation. And as you can see, there are now an additional 6 or 7 files here, PNG files. And we can go and ask our Finder to show us what those files are. So the first 6 or 7 files in this folder are the VTP files that Tim gave us half an hour ago. And this is the visualization that you have just generated. Okay. And so that is a brief summary of how you might use VTK libraries, graphical user interface, interactively. This is what you should do to use ParaView till you get exceedingly comfortable with all the filters, with all the options that it has. And after that, Jeremiah is now going to teach us how to do it and in an even more fast and quicker manner.
Okay, I'll be sharing Jeremiah's screen right now.
So I should stop sharing. I have stopped sharing. So since this is a pre-recorded video, you do not have to record this again. It's open for discussions. Tim, do you have an opinion? Do you have any comments, please?
Not
hear you. Cannot
no,
hear you.
You can't hear me?
Cannot hear you.
I think I can hear Tim.
Yeah. Is your volume on?
Okay. Sorry, my mistake. My mistake.
Yeah, not too much to comment on, but I think that that presentation really outlines the importance of at least, you know, being able to navigate these programs using the command line and using the binaries, just especially when we're doing such large jobs, like he said he has like thousands of files, right? And so it's nice, it's good to be able to kind of use the graphical user interface, and if you're kind of testing out your visualizations, it's good. But when you're making these kinds of like large jobs with your finished results, it's definitely better to have it using the command line, and especially for automation, so that you can recreate the jobs. Like, it's one thing to, you know, click through the GUI one time and make your picture nice, but then if you need to redo your simulation and then remake the figure, if you just click through the GUI one time and you don't really know what all the options that you set up and you can't remember that, being able to make these like automated scripts is really key when it comes to that, making your finished product in terms of your visualizations.
Clara, do you have any comments?
I think on my end, it's similar to what Tim was saying about just the power of automation, because personally, I've really only used ParaView for the smaller scale image visualization. So I think the platform itself, though, is very, I would say, user friendly, and navigating it is pretty intuitive. So I think scaling it up with the Python trace for larger processing tasks is a very useful thing to know how to do. And
so have you now changed your mind, and will you become an engineer rather than a medical doctor?
I don't know about that. Maybe I will integrate it in as if I ever need to use it, I will.
Well, thank you. Just to sort of reiterate, Clara is firmly installed in several studies, several of our activities. And she is rather a force over here. Clara, everyone. So, Keith, is there something that you wish that we did differently?
Preliminarily, I'll just say that I did meet Clara at the London Health Research Day, and as you say, Dr. Karchi, she's a formidable force on her own. So I really liked the poster that you presented there as well. It was really good. And also, in addition, like I was just saying, it's a little bit serendipitous, Dr. Karchi, because I kind of had to learn terminal on a Mac recently. I'm used to using DOS, I'm used to using Windows, so that's kind of what helped me follow a lot of the tutorials that you did, as well as Jeremiah's. And that's exactly, like, I agree with what Tim mentioned, which is that they're good for automation. On one hand, you look at it and it's 1 hour presentation to do something that you did in a lot of a shorter time span, Professor. But when you have a lot of jobs and you have a lot of things, automation is the only solution. And automation, I've learned you can't do through GUI. And so that's where terminal can come in handy. I use LaTeX a lot to typeset some of the documents I write. And I had to develop something recently because, if they have bibliographies and they have nomenclatures, those are compiled separately, and it's just a headache, even with however good of a GUI you have in order to do them all. So that's where the terminal aspect that Jermiah was discussing, I think, comes in handy. And if you have a terminal implementation of the software, I always appreciate like a user interface, but I feel more comfortable if I know that I can always access something from a terminal, which is the majority of what Jermiah was presenting.
Besides, I believe what Clara means to say is that your lives, not mine, but definitely Keith, yours and Tim's lives are precious enough that you're not to waste it watching paint dry. Okay, so as soon as you're happy with a view, as soon as you're happy with a color scheme, as soon as you've shown the biophysical quantities that you want to show in your visualization once, then you may wish to just modify that during your production runs. Watching paint dry means if you have 1,000 files, it takes several hours. I don't know how long. It might take less on a gaming computer, but it might take long enough on a gaming computer as well. So it takes a long time for data to go from here to there, even as you have high-speed interconnects. Yeah. Secondly, a graphical user interface is heavy on the memory. And Tim is right now running aneurysm 1, 2, 3, 4, aneurysm 24, and then he's running some aortas. And so somewhere he has to optimize on use of memory. And all of these things together, importantly, what happens is if you are preparing some really brand new sort of paradigm changing research, the best way to do that research is to write it down. You're not supposed to remember where I clicked day before yesterday. Write it down in a Python script. Write it down in a Python script. And so your image, your result is exactly reproducible down to the last pixel.
Consistency.
Consistent reproducibility. Reproducibility is an immense issue. You think that with the going on of human progress, there would be more reproducibility, but unfortunately we have now less reproducibility in everything that we see coming out. And
I can appreciate that.
This is a small piece in the reproducibility factor.
Yeah. It's only going to get more relevant, I believe. Like it kind of comes full circle with the themes that you were discussing in yesterday's presentation about document hygiene, which lends itself to social hygiene. And I think having a software that can be implemented at terminal or any kind of manner of automation is in itself a type of, I think, something that only increases the marketability or uptake, as we were describing, of the software.
Lawrence, do you have any comments? Right, Lawrence? Lawrence
no, I agree with everything you guys have said. Yeah, I think like the user interface is pretty easy to use and everyone should have like an easier time using that.
Okay. Riva, do you have something to add to this?
This is all very new to me. I haven't really used a lot of these softwares that were kind of mentioned today. So it was interesting actually because they look very intimidating at a first glance, but through the tutorials, they did seem quite, yeah, exactly. Not as intimidating anymore and kind of interesting to potentially use in the future. So yeah, it was really a good tutorial, all of them.
Thankfully, we have turned at least one person today. We've turned at least one person today. So,
Riva, are you in second year or third year?
No, I'm going into my 4th year.
4th year, okay. Yeah, because I was about to say most of these methods, I don't think it's kind of surprising actually. I came into medical biophysics with a little bit of past experience and research, and you grow an appreciation for things that are taught to you and you learn, and then things that aren't taught to you and you have to learn on your own. And I think especially Tim being in grad school, he can probably attest to that, where if you don't know something, nobody's going to sympathize with you. You need to learn them on your own or you drown, including terminal, including, typesetting. When you get to that, like everything, it's so, yeah. But terminal is a nice kind of framework where, different people have different experience with different GUIs, but if you have experience with terminal, you can go anywhere. I mean, all software when it comes to terminal are the same in a sense of grammar and syntax.
People who use Microsoft Word to do all their writing do not make money off of Microsoft Word at all. It is people who made Microsoft Word, the program Microsoft Word, have made bucket loads of money. The people at Microsoft who make Microsoft Office and Word and everything in between use the terminal to make Microsoft Word, which then becomes useful on the mouse and the brightness and the colors and the fonts and whatnot. So all this point and click solutions that you see here, if you are not selling something, you are the commodity. If you are not selling something, you are the commodity. You are being sold. So there you go.
That's a good point.
Yeah, but Riva, I'm never paying for that bagel, right? I will not pay for that. Okay.
Bagel is on me. No
I will
worries.
not pay for that bagel. All right.
I still don't believe that you received a plan